Assalamualaikum! How are you today? I hope you're doing really fine and ready to explore some science today. But first, let's start the class with saying Bismillah. Bismillahirrahmanirrahim. Do you still remember of what we learned last week? Yes, it's about relative atomic mass, relative molecular mass, mole concept, also molarity. And today we're gonna talk about stoichiometry. Let's go! So stoichiometry is basically defined as the quantitative relationships of reactants and products in a chemical reaction. So what exactly does that mean? It is actually about how we gonna understand mathematically that everything that written in the chemical reaction relates to each other. Imagine for a second that you're home alone and craving some grilled cheese sandwiches. So you call up your friend and say, "Hey, how do you make a grilled cheese sandwich?" "How much bread? How much cheese?" you ask. 2 slices of bread and 1 slice of cheese is all you need to make one sandwich, he said. So there you go, you've got your recipe. In chemistry, the recipe is the balanced chemical equations. So where does stoichiometry come in? Let's suppose you're super hungry and you want to make 7 grilled cheese sandwiches. You need to know how much of each ingredient to use. Let's start with the first ingredient. How many slices of bread do you need to make 7 grilled cheese sandwiches? In order to solve this problem, we are first going to write down the quantity that we know, 7 grilled cheese sandwiches. Next, we are going to multiply this by the ratio of bread to sandwiches. You need 2 slices of bread to make one sandwich. But where did I get those numbers? Well, the recipe or balance equations actually tells us the ratio of the ingredients and products. Sandwiches on the top and bottom cancel each other out and we are left with 7 times 2 slices of bread to make 14 slices of bread, which is our final answer. Notice that this is a really unique conversion problem and the balance equations is our conversion factor. Let's take a look at a very simple reaction. Hydrogen reacting with nitrogen to produce ammonia. It is not balanced, so we'll have to add some coefficients. Mastering stoichiometry requires an understanding of what coefficients represents for. First, what they relate to each other. Second, what information can be derived from them. And third, how to manipulate them mathematically. So in other words, it's all about how can the coefficients be used to quantitatively connect all substances in a reaction. In this case, the coefficients represents as the ratio of the reactant and products in the reaction. We really have to understand what those coefficients are telling us. If they are referring to a specific amount of particles, that will tell us about how many particles are reacting and how many particles that will be produced. For example, the way the reaction is written as we are looking at it right here. So we would have 3 hydrogen molecules reacting with 1 nitrogen molecule and that produces 2 ammonia molecules. So let's see how that works. The 3 hydrogens collide with 1 nitrogen and everything is broken apart and referred as 2 ammonia molecules. In our everyday world, we are working with massive amounts of particles, and so what the coefficients can actually tell us are simply the ratios of what is going on in the chemical reaction. For example, if we have 6 hydrogen molecules, they are going to react with 2 nitrogen molecules. Or, if we have 9 hydrogen molecules, they are going to react with 3 nitrogen molecules. So, what I'd like you to be able to see here is that even with large amounts of molecules, this reaction still occurs with a ratio of 3 hydrogens to 1 nitrogen, producing 2 ammonia molecules. And with this particular reaction, it will always react in that 3 to 1 to 2 ratio, no matter how many molecules you have. Let's back up just a moment. So what's really going on here? So 3 hydrogens reacting with 1 nitrogen, giving us 2 ammonias. But that's really just a ratio. So no matter how many you have, it's always going to be with this reaction in a 3 to 1 to 2 ratio. And so the coefficients of any chemical equation give the ratio of reactants to products in the reaction. The ratios can work for us mathematically, because we use a very large amount of molecules, but the ratio remains constant. And now we can see how this all connects to molar amounts of particles. Take a look at the last line. We can actually see that the coefficients are molar ratios, because 1 mole is equal to 6 times 10 to the power of 12, remember? So we have 3 moles of hydrogen molecules reacting with 1 mole of nitrogen molecules, and that produces 2 moles of ammonia molecules. So the coefficients being ratios, and they can represent any ratios, including molar amounts. And because we are using such a large particles, we use the coefficients as molar ratios. Let's see how the ratio can work for us stoichiometrically. Keep in mind, if the mathematical relationship given by the coefficient ratios hold constant. So in the rest of the video, we will be looking at the various examples to build up what you might normally see in the stoichiometry textbooks. We will look at a mole-mole calculation, mole-mass calculation, and mass-mass calculation with additional simple steps that will help you out. First, of course, the easy steps that will help you out, there's balancing, and then convert it to moles, and then use the mole ratio, and last is convert the moles to the desired units from whatever the question is asked about. Please pause the video and take a note because it is hugely important. Done? Now, you're ready to jump off some examples. Let's look at an example using this reaction of hydrogen and nitrogen. So if we have 7.5 moles on hydrogen, how many moles of nitrogen would react with that? First, we balance the equation first. Yep, that's balanced. And then, because it is already given mole, so we don't have to convert to mole for the second step. Next, we use the coefficient ratio of 3 hydrogens to 1 nitrogen to determine the answer. The amount given in the problem is 7.5 moles of hydrogen, and we multiply that by a fraction that represents the coefficient ratio, the 1 nitrogen to 3 hydrogen ratio. Remember to always putting on top that we want and on bottom what we have. So it tells us that 2.5 moles of nitrogen will react with 7.5 moles of hydrogen. And for the last step, because the desired unit is mole, so we don't have to convert it anymore, and voila, the answer is 2.5 mole of nitrogen. Now you try it yourself. Here's the reaction of sulfur and oxygen, and here's your steps. Please pause the video and take your time to do it. And here's the answer. You got the same answer? Wow, you're such a clever student! So this is always the central part of the stoichiometry calculation, the mole-mole conversion. These mole-mole connections always follow the same format, where A is the amount given in the problem and B is the amount that wanted in the problem. And multiplying by the coefficient ratio gets us from moles of A to moles of B, and the moles given to the moles wanted. But there is a problem with this. We cannot directly knowing the amount of moles, because we cannot count on amount of mass, particles, also volume. Interesting, isn't it? Let's take a look to the next conversion. So this is the mass-mole calculation, means we can expand the map to convert the mass to mole. Here is our ever-present mole conversion. You can convert it to moles using molar mass and then convert it to moles wanted. We can now see how this map can guide us in a mass to mole stoichiometry problem that involves two unit conversions. Here, I give you the decomposition of potassium chlorate. No, don't be panic. I guarantee it is as easy as it seems. The question is how many moles of oxygen are produced by the decomposition of 15 grams of potassium chlorate, and it is known that the relative molecule is 122.6. Okay. So here's the steps again. Now we balance. There we go. And then we convert the given mass to mole. After that, as usual, we use the coefficient ratio to find the wanted mole, yep. And voila! Hold up, is that mean we can convert to mass too? Let's expand the map a bit more. We just did the same and finally convert moles wanted to mass wanted using B's molar mass. Here you go. Now, let's go to the last example. Here, I have the decomposition of auric chloride. And the mission is we have to find how many grams of chlorine that can be formed when we know the mass of auric chloride is 65 grams. As usual, here's the steps. First, we balance them, and then convert the mass given to mole. After that, use the mole ratio. Finally, we convert the mole to the mass that is desired in the asked question. Yep, that's the answer. Yay! How was it? It was all super easy, right? So stoichiometry did not as hard as it seems. Don't forget to do the couple of exercises in this QR code. You can pause the video and scan through here. And those questions will be our today's assessment. And it is a super easy quiz, if you pay attention, of course. And next week, we're going to expand the stoichiometry maps into particles and volume conversion. So that's all for today. I'm going to end this class with Hamdalah together. Alhamdulillahirabbil alamin. Keep smiling, be grateful, and bye-bye. Wassalamualaikum warahmatullahi wabarakatuh. See you next week.